All right, let's look at the homework 2.1, problem number 7. All right, so we want to find the equations of the line that is tangent to the given function, but also parallel to the given line. All right, so let's do that. All right, so let's see. So to find the equations of line, we need a couple things. And remember that we need to find one point. So we have x1 comma y1. And unfortunately, we don't know this yet. And number two, we need to find the slope. So I'm going to call it m. And this is going to be equal to, right, so we just need to find the derivative of this function and plug in the x1 value. So that's how we do that, right? All right, so since this is a section 2.1, we don't know the derivative rule yet, so we're going to have to use the definition. So let's go ahead and use the definition, find the derivative. All right, I'm going to do it here. So we want to find f prime of x, which is equal to, right, limit as delta x approaches 0, right? Then here the function is x cubed plus 2. So we're gonna do x plus delta x cubed plus 2. Right, so that's f of x plus delta x, and a minus, and we're going to have to subtract the f of x, which is x cubed plus 2. And then we're going to divide through by delta x. Right? Then we just have to multiply all out, so you have a limit as delta x approaches 0, so we'll do that later, and then we just have to multiply out. So I'm gonna draw a long line here. If you multiply out, you're gonna get so cube, right? So it's gonna be x cubed plus 3x squared delta x plus 3x delta x squared and plus delta x cubed. All right, and you have a plus 2. Actually, I'm going to go ahead and, since you have a 2 minus 2, so 2 minus 2, I'm going to go ahead and cancel that beforehand. And then we have a minus x cubed. All right, and then all over delta x. Right? So we can cancel x cubed here and x cubed there. Right? So you have the three remaining terms. They all have delta x in common, so I'm going to just factor out the common factor. So limit as delta x approaches 0. All right? Then you have, so delta x is pulled out. Right, what's left is 3x squared from this term, right? And then if you pull out the delta x from there, you're gonna get plus 3x delta x, right? And then we're gonna pull out the delta x from delta x cubed, so you're gonna have delta x squared, right? And I guess I have to change this to a bracket so that I don't get confused. So here, right, then you have a delta x on the bottom, right? So we can cancel delta x on top and delta x on the bottom, and remember that the delta x goes to 0, so this guy goes to 0 and that guy goes to 0. So this second term is going to go to 0, and third term goes to 0. So only thing that's left is 3x squared, right? So this is equal to 3x squared. Alright, so we know that this is going to be 3x1 squared. Alright, and also since we know that these tangent lines are parallel to this given line, I'm going to find the slope of this given line. Right? We can simply add y to both sides, then you can get 3x minus 4 is equal to y. So we can see the slope is equal to 3. Alright, so we can set this slope equal to 3. Then we can solve for x1. So let's do that. So first we're going to divide through by 3 to get x1 squared is equal to 1. Then we have take the square root of both sides. Then we know that x1 is equal to plus or minus 1. Alright, so we actually have two separate values. So x1 is going to be, so I'm going to call this guy tangent line number 1. Right, so x1, let's do the negative 1 here. So you have a negative 1. Right, if you plug in negative 1 into the original function, so let's see, negative 1 cubed, so negative 1 plus 2, so it's going to be 1. So that's tangent line number 1. Right, then tangent line number 2 would be tangent line number 2 would be we're going to use 1. Right, so we have to use a different point, x1 comma y1. Right, so the other one is a positive 1. Right, if you plug in positive 1, you get 3. So corresponding y value is 3. And of course, that slope is 3 because it has to be parallel to the line. Alright, so let's find the equation. So the equation of the tangent line number 1 would be, it's going to be y minus, y1 is 1, is equal to, slope is 3, and x minus negative 1, so it's going to be plus 1. Right, I'm going to go ahead and distribute 3 to x and 1. So we get 3x plus 3. Alright, then I'm going to actually move this 1 over there. So by adding 1 to both sides, so we have y is equal to 3x plus 4. Right? Let's find the tangent line number 2. Right, so it's going to be y minus y1 is 3 is equal to, slope is 3, and x minus x1 is 1 for this one. So you have, again, I'm going to distribute the 3 to x and negative 1. And we get 3x minus 3, right? Then we can simply add 3 to both sides so that we have a y is equal to 3x, right? So let's type it in, and let's see, I'm going to go here, all right? So smaller y-intercept is the y is equal to just 3x. And the other one was 3x plus 4, I believe. All right, so let's type it in. Submit for testing. All right, it came back and looks like we got both of them correctly. All right, that's it. I hope that this was clear.